wires. And then the applicability of the design to autonomous, that should be autonomously, or autonomous oceanographic and or ocean racing. Well, that's just a big sentence that means nothing to me. But what it really means, I reckon, is does it sail? And I think Colin has set up 100 metres sail A to B, presumably, is it?
Yeah.
And
on a beam reach.
Yeah. And if you're able to do that, then clearly you've met that criteria. So there are 1, 2, 3, 4, 5 criteria for a maximum of 10 marks. Is that all right? So if you're presenting your things, could you please bring out the hull design, the rig design, the software design, the electrical design, and whether or not it's sailed or whether it is going to have a go at being sailed anyway. Is that all right?
Yep.
Okay.
So we have USNA and the Seascope
I'll do
first.
Okay. This is, we ended up naming the boat Peep as a development from Moo. This is the Portable Electrical Engineering Platform. And also, for any of you who are familiar with Easter, they're the little yellow fuzzy Peep candies. And this looks just like it. So the whole graphics are coming later, which will look like a Peep. And so as we said, this is the Peep Show. And presented by the Naked Scientists. Okay, hull design. This is a Maximoop. The Maximoop was a boat I designed almost a year ago, and for the Welsh, and they built this as hull number 1. So we took
number 2.
Or number 2. So the hull shell was a basic polyester hull shell. We went out, got some lead ballast, around 6 kilos of lead ballast, poured that in last night, encapsulated with epoxy, so we got the stability. We went out and got the plywood deck with stringer reinforcements in the key locations. The mast deck is reinforced, and otherwise it's a. Oh, and then we designed a rudder. This is not a official NACA section, but it is an airfoil section. It's plywood over a carbon fiber tube. You got a yoke going to the servo. The rig design is we decided to somewhat plug and play. That's the Seascope basic rig. And what we've done is to increase this, because there's more stability in the boat, to strengthen the rig. We've got a little bit stronger shrouds, and we're in the process of building some spreaders that will go on there in a second. We firmly believe that you should be able to sail quite well, and we should be out on the water about an hour after the presentation. That's our expectation. Matt.
So part of the Peep Show, we're going to open the boat up and see what's inside. So we have a hull controls package that is caught in everything. It's removable, so we can work on it. It focuses on the Rabbit microprocessor. We're taking an analog to digital voltage measurement for the wind sensor. We're using the GPS in course over ground. Because of all the metal in a small area, we said the compass was just not going to work. Integrated are the pulse width modulated signals for the rudder, and then what will be for the sail servo. The sail servo will fit through the deck, so it will be watertight. We have these through fittings, which are watertight, gasket sealed on the bottom, that the wires will go through and then connect into this. Kind of quick connects. Did I hit all the top?
Software.
Software, yes, the software. Processor. So the software is written for this, should plug and play in. We did that last night. Again, the analog to digital converter will sail upwind according to apparent wind angle, and then downwind to the compass, so that minute error in the course over ground will still be able to sail upwind. Course over ground will not let us sail upwind, so that will be our fix for that. There's also, we'll have the full navigation complement to be able to sail to multiple marks and come back.
Could I ask how much of this is new, or how much of this is recycled? There's no wrong answer here.
Yeah.
I think it's fine.
Yeah, there's no wrong answer. I'm just interested.
New and recycled.
So
the
none of this
cover is new.
Well,
The plywood was new.
Sure.
They've used. Rig is essentially recycled.
What I meant was in terms of thinking.
so
thinking.
So we brought none of this here.
Yeah.
It was just spares. We had no intent to build this. We found someone with a rig. We found someone with a hull. That's not our hull. Even though the hull design is not ours. We stole some guy's plywood in the back of his pickup truck, and you know that's not true because there's no pickup trucks. And these are all spares integrated between us and Seascope. So.
But is there anything on this that has never been done by you before? either in code or in.
Well, the hull's never been tested.
The rig's never been used.
Right, rigs.
Okay.
I've actually never steered by cog either, so.
What is the wind sensor actually?
It's a
Potentiometer.
potentiometer.
It's actually a two-phase potentiometer, so it doesn't have dead zones. But
It's linear.
Yep.
but for simplicity, we're just using a single phase and
Yeah.
pointing the dead zone.
A to B rather than B back to A.
So essentially, we started yesterday at noon thinking about this.
So this is 24 hours work.
24 hours worth. Yeah.
Okay. Yeah.